Welcome to the third tutorial on models of the atom. In this tutorial, we'll be looking at the gold foil experiment and answering the following questions. Is the atom really like plum pudding? What happens when gold foil is bombarded by large positive particles? And what does this tell us about the atom? So a little background, the person who did the gold foil experiment was named Ernst Rutherford. He was from New Zealand, and his early work was in looking at radioactive elements. In fact, he won the Nobel Prize in Chemistry in 1908 for investigations of the chemistry of radioactive substances. So in these investigations, he found that alpha particles, or alpha radiation, are in fact helium nuclei. In other words, they're large, positively 2 charged particles. So he used these particles in the gold foil experiment. Here's how it was set up. On a tabletop, he put a very, very thin piece of gold foil. He pounded it out very thinly and put it in a circular detecting screen. And the screen was made of zinc sulfide, and this has a property: when it's hit by alpha particles, it flashes or it glows. So he actually had a detecting, like a telescope almost, that could go around this detecting screen to notice where the alpha particles would go. So he decided that he was going to bombard this gold foil and see if the alpha particles went through it or were deflected a little bit, as it would be if the atoms were like a plum pudding. You'd only get a really, really small deflection. The alpha particles that he used came from the radioactive decay of radium. So what he found was, when he bombarded the gold foil with this beam of alpha particles, most of the particles went straight through the foil, but some of them were deflected at a large variety of angles. In fact, angles that were far greater than 90 degrees, which was super surprising. It was not what they would have expected if the atoms were made up of a large positive blob. They would have expected that these deflections would have been a lot smaller. So the results of this experiment was that most of the alpha particles passed straight through the gold foil, but some of the alpha particles were deflected at a wide variety of angles, and some even were deflected at greater than 90 degrees. So the conclusion that we have to make here is that atoms are mostly empty space, since most of these big particles went through there, and there's a very dense positively charged nucleus, because if most of the alpha particles went through, but some were deflected at a large angle, it must mean that the positive alpha particles are getting repelled from the really dense positive nucleus. So further experiments showed that the atomic radius is about 100 picometers, and the nuclear radius is 5 times 10 to the negative 3 picometers. So what does that mean? That's crazy. It means that the size of the atom is about 20,000 times the size of the nucleus. So this is a very astonishing conclusion. The atom is composed of a very dense, small, positive nucleus, and that the electrons are somewhere around that nucleus. But the question is, where are the electrons and what are they doing?